A very good afternoon, everyone. I am Madhuri Bhattacharya. I am Prime Minister Research Fellow here doing research under Dr. Karthik Chandra Mondal in Department of Chemistry. Basically, I am doing research on sensitive chemistry like radical chemistry, carbene, double carbene radicals, and then application of those radicals for nitrogen activation. So I have done my master's on analytical chemistry, and I'll be guiding you in this course, Industrial Inorganic Chemistry, which has been taught by Professor Debashish Rai, Department of Chemistry, Indian Institute of Technology, Kharagpur. So I think all can hear me, right? I'm audible.
Yes, miss.
Okay.
Yes, miss.
So please introduce yourselves also. Mahesh Dange, who is this person? May I know? Mr. Mahesh Dange. Hello. Am I audible to you?
Yes, you are audible.
Although
a little, okay, I think he might be facing problems.
Yeah. So others, Partha Pratimnath.
Yes.
Introduce yourself.
Hello.
Yeah, you introduce yourself.
I am Partha Nath. I am pursuing my master's degree from Viswabharati University.
Okay.
Now I am second year.
Okay. Thanks, Partha Pratim. What about Shivagami?
Yeah, this is a little broken. I'm getting you a little broken. Is it?
Oh, is it broken?
Is everybody else okay? A little broken.
Is it broken for all? Hello.
Yeah, let other people respond.
Yes, miss, you're clear. Your voice is clear.
Okay, so it's my problem. Okay, all right. Thank you.
Okay, thank you. Other people can introduce, please, or else I will start the class.
Yeah, hi. My name is Rajiv Naran, and as you can see, I am quite old. I finished my chemical engineering from IIT Delhi in 1985.
Okay.
But nowadays I lead I'm still a chemical engineer, and I lead a program called Process Economics program of S&P Global, which is a very geeky kind of chemical engineering program evaluating technologies.
Okay.
And I'm a lifelong learner, so I want to update my skills on inorganic chemistry, which, by the way, is becoming very important from the climate point of view, because it doesn't have the carbon atom. So, which is why I'm here, and thank you.
Okay. So I'll be starting the class now. Let me share my screen. My screen is visible to all?
It's loading.
Is it visible for everyone?
Yes, I can see it now. Yes.
It's visible, right?
Right. Yes.
Okay. Thank you. So we'll be discussing on this course, Industrial Inorganic Chemistry. This has been taught by, as I have already told, Debashish Roy, Professor Debashish Roy from IIT Kharagpur. Then This is my details. So course outlines you have already got in the course, and I think up to second week it has been covered so far. So we'll be discussing step by step. So basically, industrial chemistry, inorganic or organic or physical, both are having all are having industrial applications in agriculture, environment, food, hygiene, refining products, recycling the products, then construction materials, also developing several catalysis. So there are several applications. Okay. So I'll start with very basic question. Example of mineral fuel. Four options are given: coal, iron, bauxite, and gold. So anyone can respond? Anyone can respond? Oh, sorry. What will be the correct answer?
Coal.
Okay, coal. One person. Oh, who are you? May I know your name?
Mineral fuel.
Parthavatinath.
Okay. So that is correct answer. Coal is a mineral fuel. So basically, what is called mineral fuel? Mineral fuel means that is derived from some organic biomass. Basically, some large amount of plants, when it is deposited for long years, then by some biological processes it will be converted to some hydrocarbons, that is called mineral. And fuel means it will be producing some energy when it will be burnt in oxygen, that's why it is mineral fuel. So coal means some hydrocarbon. This is the coal combustion process, where this is the schematic diagram. This coal will be first grinded to some powder, and then it will be inserted in the combustion chamber, where some boiler will be introduced, which will supply the heat and oxygen. Then in presence of oxygen, hydrocarbon will be burnt, and product will be CO2 along with this energy, and this energy will help this water. Here actually water boiler is present, so liquid water will be absorbing this energy, and it will be converting to steam. That steam will be passed through this turbine. Then turbine will start rotating, and it will produce some sort of energy. That energy will be interfering with the generator's magnetic field. So magnetic field density variation will be happening, and by that way some electricity will be generating, that we will transfer to the transformer, and finally electricity will be supplied as per the desirable uses. Okay, so this is the general coal combustion process, where hydrocarbon is becoming converted to carbon dioxide. This I have represented as C, but it can be any hydrocarbon, not only carbon, hydrogen plus carbon. So coal is basically a special type of economic deposit. Why economic? Because some sort of energy we are generating, right? So that will help to balance our demand of electricity, and then energy demand. So that is fulfilling our economic need. That's why economic deposit, and it is having high concentration of carbon and hydrogen. It is formed by biological process, and the product of accumulation of large plants under high pressure and temperature. So this is basically the production, how it is produced by large high temperature and pressure. Over the years it will be produced. Okay, so next question is, what do silicate minerals contain? Silicate minerals, what is the structure? Anyone knows? And then only we can answer this question. Silicon, oxygen, both, A, B, none of the above. Give the response.
Silicon and oxygen both.
Yeah,
Okay. So do you know the
I
formula?
agree.
Silicate materials, silicate minerals. Here also we are telling minerals. So this is naturally occurring, we can say. Any other responses? Silicon, oxygen. This is simple question. I will move forward.
Silicon oxide.
Ah, so silicon and oxygen both. That is the correct answer.
Yes.
Like aluminosilicate.
Okay.
Alumina silicate, that's right. Al2SiO3. Yeah.
Okay. Just a minute. I think my PowerPoint is little hanging. Just a minute. Yes, the correct answer is both the silicon and oxygen. So this is silicate means SiO2, polymeric SiO2. Depending upon the temperature and pressure involved in the formation of silicate, it can vary the composition. It can be orthosilicate, metasilicate, sheet type silicates. Several structure is possible, but the elements involved in silicate formation are silicon and oxygen. This is the general formula SiO2 O2N 2 minus, and also to balance the chart, several typical cations involved are generally potassium, sodium, magnesium, iron. These are naturally occurring silicates, and it is highly abundant. Almost 90% of the Earth's crust is made by this silicate. Generally, quartz material we will easily get. That is also made with silicate. So most silicates are formed when molten rock cools and crystallizes. And as I have already told, depending on the temperature and pressure involved while the formation of silicate, it will vary the composition of the silicate. Okay. So this is the general like monomeric structure of silicate, but it is present as the polymeric network. It can be one-dimensional, two-dimensional, three-dimensional silicate, and SiO4 SiO4 4 minus I have shown, but it can be SiO3 2 minus also, SiO2 2 minus also. Several variations are there. So these silicates are very important material. It has several applications in cement, ceramics, glass industries, and as adhesives also. Moving forward to my next question. The main methods of extracting metals from their ore is: first is reduction of the ore with carbon, reduction of the molten ore by electrolysis, reduction of the ore with a more reactive metal, or all of the above. What is the correct answer?
All of the
All of
all
the
of the above. D.
Correct. So this is our metal list, what we generally extract in the industries, where we can see from this bottom to top, reactivity increases. What does it mean? If we treat with some less reactive metal with more reactive metal, less reactive metals salt with more reactive pure metal, then more reactive metal will be converted to the salt and less reactive metal will be isolated. This is the extraction or isolation of metal with the reaction of more reactive metal. Then the second one is molten ore by electrolysis. By application of electricity also, we can split the metallic ore to metal, and then the corresponding oxide will be evaluated as gaseous product in anode. Then reduction of the ore with carbon. With carbon also we can reduce. Carbon is a good reducing agent. So if we treat any ore with carbon, and if that metal is less reactive than the carbon, then carbon will reduce that metallic ore to metal, and carbon itself will be oxidized. Okay. So these are the general schemes. Like this is the example of electrolysis. NaCl. NaCl, if we fuse, then it will produce in the solution Na plus and Cl minus. Then at anode, this here on negative charge is missing. 2 Cl minus, this will go to anode. It will be converted to Cl2, and Na plus will go, because cation this is, it will go to both are written as anode. This should be cathode actually. Cathode will attract cation, then it will be deposited as sodium metal. Like this, we can extract sodium metal from electrolysis of sodium chloride solution. Then by the reaction of carbon also, by the reduction with carbon, we can extract iron. Like you can see from this chart, carbon is placed above iron. Okay, so carbon will be more reactive than iron. If we treat carbon with any oxide of iron, what will happen? Carbon will capture this oxygen. It itself will be oxidized to carbon dioxide, and iron oxide will be reduced to metallic iron. Then third method, this is also this reaction with the more reactive metallic ore, and then reaction with some other reactive metal. From this series you can see iron, zinc and magnesium, they are more reactive than copper, right? Silver, gold, these are very less reactive. We will get in the pure form in nature, not not mixed with any oxide or anything as ore. It will be formed, it will be obtained as pure metal in nature, because these are very less reactive. But these materials like sodium, potassium, calcium, they are very highly reactive, alkaline earth material. So they will never be stable as metallic form in open atmosphere. They will be obtained as always as some ore. Okay, so for their extraction, we can use this method, like iron and copper chloride. If we react both of them, then being more reactive, iron will be oxidized to iron chloride, iron 0 here oxidation state, and here it will be +2. Then copper chloride, copper will be reduced to metallic copper. Like this, same copper ores can be treated with any of these metals, because all are more reactive than copper. So we can extract copper in this way.
Madhuri, can I
Yes,
just request something? I'm also doing another inorganic chemistry course,
Okay.
and there they presented what is known as the Ellingham diagrams.
Okay.
And Ellingham yeah. So I think I found it very very interesting. Okay, and because that will tell you at what temperatures you can reduce the ore, and more important also, instead of using carbon nowadays, people want to use hydrogen as their using agent. So Ellingham diagram also makes it clear what are the challenges with using hydrogen instead of carbon. Just a suggestion, man.
Okay. I was not knowing this diagram, about this diagram. I will obviously go through this.
But please look at it. It is very very interesting. Ellingham diagram.
Ellingham
Thank
diagram.
you.
Thanks, sir, for your suggestion. So next question. The method other than galvanizing in which a more reactive metal is used to prevent rusting among the following is electroplating or sacrificial protection or electrolytic protection, or none of the above. Which will be the correct answer? Anyone?
It can be electroplating.
Actually, all are quite similar. Question itself.
All are similar.
All are quite similar. Actually, all will involve two electrodes and one electrolytic source. Okay, one electric source involving two electrodes. So all are quite similar, but little more specific if we want to say. Galvanizing means some kind of coating we are making, right? method other than galvanizing they are asking, in which a more reactive method, a more reactive metal is used to prevent rusting. Rusting means what? So what material we want to protect? Iron only, right? Because rusting means iron oxide, that is called rust. So rusting we are preventing means we want some coating on our iron cathode or anode, whatever. On our iron electrode we want some coating. So that is called actually sacrificial protection. Electroplating also, yeah, electroplating also we can say, because that is also putting some coating on one of the electrode. That is also true, but more specific if we want to say, then it will be sacrificial protection. Why sacrificial? Because one electrode is sacrificing itself to protect another. So that specific method is called sacrificial protection. One electrode will be slowly decomposing, and another electrode will have that coating of that electrode. I'll show the diagram like this. This is the metal, iron metal we will use as cathode. Why? The material we want to protect, we will always keep it as cathode, means we will apply the negative charge here. The battery we will connect so that this will become negative. Negative potential will be here and it will be positive potential. The material which we want to coat. So this is the general convention of electroplating or sacrificial protection, whatever. This is the general convention. Cathode, we have to choose the metal which we want to protect, and anode will be the material which we want to coat. So the explanation is like protection of iron or steel against the corrosion by using a more reactive metal. So when this anode will be reacting, when it will be more reactive than this cathode. Okay, this is the general logic. Just a minute, I think someone wants to join. Yeah, anode we should choose such material which will be more reactive than the cathode. Then only this electrolysis will be happening. What will be happening? This anode here we have chosen zinc. Okay, zinc anode. Then zinc will be removing one electron, and it will be converting to zinc 2 plus. Zinc 2 plus will be moving towards cathode because this is negatively charged electrode, and zinc 2 plus will be slowly accepting this one electron from here. It will again convert to zinc, and it will be like attached on the surface of this cathode. It will not go back to the solution again. So there will be one coating. That is called protection layer we are making. And sacrificial protection means this zinc anode is sacrificing itself to make one layer on the cathode. So this is the general procedure of galvanizing. Also we will call it as galvanizing also. Actually, galvanization means coating of zinc on iron. That is called galvanization procedure. So this question is little contradictory, you can think, but question was like this, so I just thought to discuss. Okay, so the protected metal becomes the cathode, and it will not corrode. Anode corrodes, thereby providing the desired sacrificial protection. And sacrificial anodic material will attract the corrosion. Yeah, this is also one important point. Like when the coating is done, if we put the coated material it will be protected from the moisture and everything, because when moisture will come, it will react with the coated material. Like zinc will be more reactive, and zinc will react with the oxygen, moisture, everything, and it will be converted to corresponding oxide, and our iron will not get any rust. That is called the protection layer, right? So time to time we have to change, we have to replace this anode, we have to put again coating. This is quite like a common thing. So this was the meaning of sacrificial protection. Then what is limestone? Among the following: carbonate rock, silicate material, silicate mineral, sandstone, none of the above. What is the correct answer?
Yes. Calcium carbonate.
Calcium carbonate, correct.
Carbonate rock.
Yeah, carbonate rock. So if we see the structure of calcium carbonate, this is also, limestone is also made with calcium carbonate only composition, but its structure, its crystal structure will be different than calcium carbonate. That's why we are categorizing it as limestone. We will not call it as calcium carbonate. Composition is made with calcium carbonate only, but limestone itself is having some specific structure. So generally it is not having one particular structure, it is having a mixture of structure, and that mixture is coming from calcite mineral, aragonite mineral. So there are several, many more also, dolomite, everything is there, but it is different than the calcium carbonate crystal itself. It is not calcium carbonate crystal, okay, but composition is made with calcium carbonate. For example, here this is the crystal structure of calcite, okay, this is the crystal structure of calcite. You can see calcite is having several calcium carbonate moiety, and it is placed in this unit cell such a way it is having some unique unique arrangement, and that is categorized as calcite crystal system, okay. So limestone is made with carbonate rock only, but limestone is having different crystal structure than carbonate. Then it is a common type of carbonate sedimentary rock. Yeah. So how it is formed? It is formed by the sedimentation of carbonate in water. Limestones form when this minerals precipitate out of water containing dissolved calcium. This is the chemical reaction in presence of carbon dioxide, dissolved carbon dioxide. This calcium carbonate will again be dissolved in the water. So what should be our goal to form this limestone? That is, we should have less amount of carbon dioxide, then only this dissolution will be less favored. For that we can use any of these methods. We can increase the temperature, we can reduce the pressure. These both will decrease the dissolution of carbon dioxide. The amount of dissolved carbon dioxide will be reduced in increased temperature and reduced pressure. If carbon dioxide is less, then according to Catelier's principle, this calcium carbonate dissolution also will be less favorable, and also reduced salinity. Salinity means what? The amount of metal ions in, just a minute, I think someone wants to join. Salinity means the amount of metal ions in our water source. So if there are several metal ion present in our water, that will also increase the concentration of metal ions in our system, and that will help this CO2 to get dissolved. And if CO2 is more, then calcium carbonate will be dissolved more. So in that condition, calcium carbonate will not be precipitated out. So to form this limestone, we need increased temperature, reduced pressure, and reduced salinity. These all the conditions are found in saline water, right? Not saline water, like sea water, you can say. In the sea water system, these conditions are more profound than fresh water. That's why limestone will be more found in the seawater than our fresh water. So it can happen through both biological and non-biological process. The formation of limestone can happen through both biological and non-biological processes. So then now chlor-alkali process. This is one specific industrial process. This is asking, it is used for electrolysis of sodium chloride solution, electrolysis of sodium hydroxide solution, electrolysis of water, none of the above. What is the correct answer? Anyone already aware of this chlor-alkali process?
I think it is electrolysis of NaCl.
Correct. It is electrolysis of NaCl. So what we will do, why we are doing electrolysis of sodium chloride? Because by the electrolysis of sodium chloride, we can get sodium metal, and we can get not sodium metal, we can get sodium hydroxide, commercially available sodium hydroxide, that will have several applications, and along with chlorine gas. So both are having commercial applications. That's why we want to electrolyze sodium chloride. How we will do this process? Brine solution we will pass. Brine means just the aqueous solution of sodium chloride. Then two electrode will be there. In the anode, anion will come. What are the anions present in our system? If it is sodium chloride solution, then I will use the laser pointer. If it is sodium chloride solution, then anions are Cl minus and OH minus, because aqueous solution of sodium chloride, and cations will be Na plus and H minus. Now one membrane is there. Membrane means what? Through which ions, some specific ions can move. Not everything can move. It is not very hard separator, but ion can go through it. So with the membrane separation, we will separate both the solution, and then two electrodes are kept. One battery source is connected. Then electrolysis will start happening. Anions like chlorine and OH minus will start moving to the anode, and cations like Na plus and H plus will go to cathode. Sorry for the interruption. Sometimes having some problem. Okay, so then the reaction is like this: NaCl and H2O, NaOH and Cl2 and hydrogen gas will be formed. Like half cell reaction will be Cl minus will accept Cl minus will reject electron. 2 Cl minus will reject 2 electrons, and then it will be converted to Cl2. Then OH minus, it will also reject the electron, and then it will be converted to this H2. Not H2 will be formed actually here. OH minus is coming, and in a plus half cell reaction we have to write actually, otherwise it's difficult to explain. Basically the active species will be Na plus and Cl minus, and H2O is there, right? So OH minus will be converted. OH minus will be converted to water, and then this H plus will be converted to hydrogen. Na plus will be Na plus will not be converted; it will remain same, and OH minus also will remain same actually. OH minus and Na plus, they are not going to change actually. Then by passing NaCl solution, we will get here brine containing NaOH, and evolving species will be Cl2 and H2. Okay, so And from NaCl, Na plus is remaining, and from H2O, OH minus is remaining. Both will combine and both will pass through the outlet. And Cl minus from NaCl will be evolving as Cl2 by rejecting 2 electrons, and H plus from water will accept those electrons. It will be converted to H2. This is the electrolytic diagram, and this Cl2 can be used as water disinfectation, in the swimming pools, in the pesticides. It is a good disinfectant. Okay. And hydrogen, evolving hydrogen also, it can be used as a non-carbon fuel, as ammonia production also. This is the green source of hydrogen, right? Ammonia production, green ammonia production is also nowadays a good topic undergoing in which undergoing several research. My topic is also like my research area is also on the basis of that only, like first dinitrogen activation, and then I will try to convert that dinitrogen to ammonia in a greener way. So I also may need this green hydrogen. Okay. So this is the application of the evolved species. And NaOH also, NaOH is a commercial base we will get. So chlor-alkali process basically means, yes.
What type of anode and cathode is suitable for this?
Yeah, anode and cathode we can use like platinum and electrode we can use here. Here this electrode material are not going to take part in the reaction. It is only to complete the circuit. So any kind of electrode what is not going to participate in the reaction we can use. Generally platinum, palladium, this kind of electrode we can use. Is it fine for you?
Okay.
Okay. So this is the electrolysis of sodium chloride, and it is to produce commodity chemicals like chlorine, sodium hydroxide, etc. Now, which of the following is not generally considered as an application of silicon? Silicon means only elemental silicon, Si. Turbine blades on a wind power farm or glass used in making windows for house, integrated circuit chips used in computers, cable TV and internet communications over optical fiber networks. Anyone can answer? Which is not the application of silicon?
I'm guessing turbine blades.
Correct. Turbine blades will not have silicon. Yeah. So silicon, whenever we are going to talk about silicon, what thing comes in our mind first? That is, it is highly abundant. Okay. It is highly abundant, just the second most abundant element by mass in our earth crust. And the silicon dioxide, what we called like silicate, we have already discussed, right? Orthosilicate, metasilicate, that is having several applications. That is also readily abundant mineral in our earth crust. And silicon dioxide also we will get. Silicate mineral, from silicate mineral we can easily extract the silicon dioxide, and this is used in making glass, ceramic products. In these products also it will not be like silicon dioxide, it will be like silicate. It will convert to silicate only. And also being semiconductor, it is used for making transistors. It is widely used in computer chips and solar cells also. And nowadays silica optical fibers are also manufactured using fused silica. So these are some applications of our silicon, but in turbine blades we will not use this silicon. So this was the correct option. Now the alloy of which material is used in aircraft manufacture? Aircraft manufacture means like keeping this in mind, what can be the suitable metal? Anyone can answer? Iron,
Aluminium.
Yeah. Why aluminium? Because whenever this is aluminium only answer. Now why aluminium? Because when we are talking about aircraft manufacture, we have to consider these factors. It should be lightweight, it should be corrosion resistance, and it should have high strength for tolerating high pressure and temperature and vibration. All these things, aluminium is able to show. That's why aluminium only we will use among these options, but we will use other metal also. Like you can see, it is made with steel also, titanium, some amount mixture of composites also there. So aluminium percentage is 20% only, but among these options, correct answer was aluminium. So that's the thing. Now, which one of the following chemicals used as fertilizer? Ammonium nitrate, potassium chloride, magnesium sulfate, sodium phosphate. What is the answer?
Ammonium nitrate.
Ammonium nitrate.
Okay. Ammonia. Now fertilizer. Fertilizer means, what is called as fertilizer? That will supply some nitrogen source, right? Why nitrogen source basically we need in fertilizer? Because that should help in protein synthesis. Then only we will call it as fertilizer. So anything that is having nitrogen content, that will produce nitrogenous species to our plant, and that nitrogen will be converted stepwisely to from amine to nitrate to some amino acid, then from amino acid to peptide, then polypeptide, and finally it will help in protein synthesis. So that is why fertilizer should contain some nitrogen source. So the correct answer is ammonium nitrate. Formula is NH4NO3. It is white. It looks like white crystalline solid consisting of ammonium and nitrate ions. It is highly soluble because this is ionic compound, highly soluble in polar solvent like water. It is hygroscopic also, but the crystal of ammonium nitrate will not contain any water moiety, but it is hygroscopic, means it can absorb some moisture on its surface. It is predominantly used in agriculture as a high nitrogen fertilizer. I think someone's mic is on. Just a minute, let me check. Okay. So like that only, ammonium nitrate will be used as a fertilizer. Then moving to the next question. What are the basic raw materials for manufacturing of sulfuric acid? Sulfur and pyrites, oxygen, hydrogen, nitrogen. This option, like, it's obvious from the options itself. Sulfuric acid we are going to synthesize means something should contain sulfur. So the option is, correct option should be sulfur and pyrite, right?
Sulfur,
Yeah. These options are made in such a way that it is obvious from the name itself. So the correct answer is sulfur and pyrite. And the process
but you could also have added water. Sulfuric acid. I think that was also one of the questions in the quiz. Is water?
Water also was there.
Yes. Water is also a.
Water will be another component, right?
Yeah.
Water also we need. Okay, so these are the diagrams of the sulfuric acid production. What we will do, molten sulfur, fused sulfur we will take, and then it will be converted, we will burn in air, in presence of oxygen. Then sulfur, elemental sulfur, will be converted to sulfur dioxide. It will be allowed to react with excess oxygen in presence of some good oxidizing agent in high temperature and at not high pressure. This is atmospheric pressure only in the presence of high temperature and good oxidizing agent we will react SO2 to form sulfur trioxide. Then, like here also in this chamber, SO2 will be passed. This is like purifier. If there is any other impurity, it will get settled here. Then pure SO2 will be moving forward to vanadium pentoxide chamber, where in presence of high temperature it will be converted to sulfur trioxide, and then we will dissolve this sulfur trioxide in concentrated H2SO4 itself. H2SO4 only we are going to produce, but still concentrated some amount of sulfuric acid we will put. Then it will be converted to oleum, H2S2O7. Then this oleum will react with water, we will dilute it, and then sulfuric acid we will get. So from sulfur to sulfuric acid to generate, we need some amount of concentrated sulfuric acid also. So this process is known as contact process, and this is the chart diagram of this sulfuric acid production. Now, which among the following process is used to obtain potable water? Filtration, sedimentation, flocculation, all of the above. What should be the answer?
My guess is all of the
Yes,
options.
all of them.
Every process is involved actually. So like flocculation, sedimentation, filtration, treatment with the activated charcoal, then chlorination also we will do to make it disinfected. Then breakpoint chlorination or ozonization, ozone gas we will pass. Then also it will remove the highly reactive radical species. So these all the things are used to purify the water. So all of the options will be correct option. Then, which among the following statement is true regarding electrolysis of water? Electrolysis of water means water, then some electron, some electricity we are going to pass, then some reaction, electrolytic reaction will be happening. So what should be the correct answer? Oxygen is produced at cathode, hydrogen is produced at anode, KOH is used as an electrolyte to increase the conductivity, and electrolysis is carried out at 373 Kelvin. What should be the correct answer?
Number C. KOH is used as electrolyte.
Correct. This is the correct answer, because here option A and B are written just the reverse. Like oxygen should be produced at anode and hydrogen should be produced as cathode. Because if we see the Hafsel reaction, here this is the anode and this is the cathode. Just a minute. This is the anode. This is the anode and this is the cathode. Cathode will be always having some negative charge, and anode will be positive charge. So towards positive charge, negatively charged species like anions will move. What is negatively charged species in H2O? That is OH minus. So OH minus will move towards anode. It will reject its electron, and then OH minus will be converted to oxygen, water, and 4 electron will be emitted. This 4 electron will be traveling through this solution, not through this solution. Here some circuit will be there, because we are going to pass some electricity. This electron will be moving through the circuit, and it will come here in this electrode, and here, since it is negatively charged electrode, some cation will move. Cation present in this solution is H+. This H+ will take this 2 electron. It will be converted to H2. So in the cathode, H2 will be produced, H2 will be evolving, and in the anode, oxygen will be evolving. And here some catalyst, although we are applying some electricity, this process is not that much facile, because we know H2O is very stable, right? So this water splitting is not that much facile. This amount of oxygen evolved and this hydrogen evolved is not good, not so good on the industrial point of view. So some catalyst is needed. So some organometallic catalyst we will design in such a way that will absorb this
like ruthenium bipyridine.
correct, some ruthenium, some heavy transition metal catalyst we will employ that will help this oxygen evolution reaction and here hydrogen evaluation reaction. So in presence of some organometallic catalyst, water splitting reaction is happening. Also this circuit is not completed here. One battery should be there, it is connected actually. Okay. So the correct option, these two are written just the reverse. And here KOH in this solution along with water, KOH also we will use. Why we are using? Like just to increase the conductivity, because as I have already told, H2O to H plus and OH minus breaking is not that much facile. Then whatever amount of ion is producing, that also will not easily move to through the solution. So to increase the conductivity, we need some good amount of carrier. So that carrier of electricity is called some electrolytic carrier. KOH is a good ionic product. KOH solution we can use here, and it will help to travel this OH minus to anode and H plus to cathode. It will help. So KOH is used as an electrolyte to increase the conductivity, and this electrolysis is never done at 100 degrees centigrade. That is the boiling point of oxygen, right? Boiling point of water. So not at 373 Kelvin, but at little higher temperature, like to produce some thermal activation energy around 80 degrees centigrade temperature we will maintain, not 100 degrees centigrade. So this option was also not correct. So only third option was correct. So these questions only I had kept for this session's discussion. That's all from my side actually. Just so we will continue in the coming week. Anyone is having any question? Please ask.
Ma'am, do we have any notes on the material which the professor is teaching? Because some is very clear and some I got confused, like that peroxide chapter. I need to read something to make it clearer to me. So, any book
Okay.
or
So
any notes?
books, I think NPTEL website they have mentioned some books, but if you are having some specific topic doubt, you can mention in the discussion forum. Then I already checked before conducting this session. There is no such question, so I didn't include any question here from discussion forum. You can mention there, and I will, if I have any notes or any particular book, I will give the reply there.
Okay, I will put that question because some lectures are very clear to me,
Okay.
but one lecture I was lost.
Okay.
He went very fast in making those equations and reactions.
Okay.
So I got lost. Okay, thank you.
Okay. Any
Ma'am,
other? Yes.
there, there in the NPTEL website, there they had mentioned that another session like 7 to 9 p.m.
Yeah.
What is for that?
That will be taken by another TA. This course has been shared between two TAs. I am one of the TA. One more TA is there. So he will be taking that session, but I don't know whether same students has to join there or not. I think large number of students is there. That's why they shared between two TAs. Some group of students will attend this session and some will be there. I'm not sure about that actually. But
But will
one
the
more session
material
is
be the
there
same,
today.
or will the material be the same or different material?
I have prepared my slides. I don't know about
Okay,
his
okay,
slides. Yeah,
okay.
yeah. What about others? Shivagami, can you please unmute yourself and speak something? Hello. Shivagami, can you hear me? Okay, I think I'm not available now. Tejal, can you hear me?
Yes, miss.
Okay, please introduce yourself and how today's class you understood anything or do you have any confusion?
Miss Tejal Hundre from Karnataka University, Dharwad.
Okay.
And miss, today's session, like almost many, like before asking me, some of them asked their doubts, so like my doubts are clear. And
Okay.
like, and I have no doubts, miss.
Okay. Okay, Tejal. So this recording I'll be uploading in one of the YouTube channel. I will share the link in the coming session, and then this slides also I will upload in Google Drive, and that link also I will share in the upcoming class. Okay.
Okay. Thank you.
Okay.
Thank you, Madhuri. Thank you very much.
Thank you,
Okay.
sir.
Bye bye.
Thank you, everyone.